Right, question number 2. We've shown an experiment here where we've got a long glass tube which is 1 metre long, and we've got point A where phosphine gas is going to be introduced there, and point B over the other side is where hydrogen bromide gas is going to be introduced. Let's just put those in. Okay, they're put in at the same time, both gases are colourless, and then the observations are really important. They reacted after 3 minutes and we saw grey fumes 20 centimetres from point A. So what that means is that we need to think about the fact that here, about 20 centimetres along, we saw these grey fumes. So let's put some grey fumes in there. Okay, so the phosphine gas has only got 20 centimetres, whereas the hydrogen bromide has got to have travelled 80 centimetres along that tube. Right, let's look at the first question then. Which gas, phosphine or hydrogen bromide, spreads the fastest, and how many times faster than the other gas does it spread? Well, the hydrogen bromide, as I've just showed you, seem to have gone the furthest, so the answer for the first part is going to be hydrogen bromide. So that's one of the 2 marks. And then we have to say how many times faster. Well, it went 80 centimetres. The other one only went 20 centimetres. So hopefully you can see that that is 4 times faster. Okay, so it's 4 times faster. Okay, what's the name given to this spreading of the gas? Okay, well hopefully you should be familiar with this because you should have seen lots of experiments on it, and it's diffusion. What is it about the particles? Okay, the particles, so specifics about the actual particles themselves of one gas which makes it spread faster than the other one. Okay, and if we think of that, some characteristics of the actual particles, it would normally be due to the size, okay, or the mass of the particles. Okay, the lighter ones would actually move the furthest, the heavier ones would take longer to diffuse. Right, what might be different in, now this is really important, the results recorded if the tube is warmed a little at point A before putting in the gases, and then we're asked to explain our answer using our knowledge of particles, and this is worth 3 marks. Okay, so firstly let's think about what would be different in the results recorded. So let's just remind ourselves by going back up again. The results were reacted after 3 minutes, where we saw some grey fumes. Okay, and they were 20 centimetres from point A. Well, whatever happens, we're still going to get grey fumes because we've got the same reaction occurring, so we don't really need to change anything about that. However, by warming point A, hopefully what you'll realise, if you think about it, is the phosphine is going to get more kinetic energy, and therefore it will probably be able to travel further, and so your grey fumes will actually occur further along the tube, so you'll probably see them somewhere down here instead. Okay, so they will have gone further, and because they're moving faster, you should also get the reaction faster than 3 minutes. Okay, so 2 points to say about it. Okay, that it's going to be further than 20 centimetres from point A, and it's going to be faster than 3 minutes. So that's 2 important points, but we've got a 3rd mark to try and get, and that's our explanation. Okay, so we're asking us to explain what this heating does. Okay, so you need to try and link the fact that the heat is going to provide kinetic energy for the particles. Okay, which means that they're going to therefore diffuse faster. Whoops. Okay. Right, part E. What might be different, again, in the results recorded if there is less air in the tube at the start of the experiment? And again, we're asked to explain our answer. Okay, this time it's only 2 marks. So the results recorded, if we don't have any air particles, we're just a little picture down here. Right, if you imagine in that tube, when we've got air in there, there's air particles kind of in the way. So as the phosphine and the hydrogen bromide are trying to diffuse, they're having to get round those particles. So if you take those particles away, they should be able to diffuse faster because there's nothing in their way. So the difference in the results recorded is it's going to be faster than 3 minutes. You're going to see that grey gas appear faster than 3 minutes. Okay, because they can diffuse more quickly. Okay, so our explanation is faster diffusion, okay, as there's no air particles in the way. Okay, and that's the end of question 2.